How are you, my friends? This is another lecture of pre-calculus course, lecture number 29 about linear systems of equations. In the objectives, we will see the definition of a system. And then there are two methods I would like to present, substitution method and elimination method. Now, when we say system of equations, it means set of equations. So it can be 2 equations, 3 or 4 or 5 or 10. The solutions of a system must satisfy every equation in the system. And the solutions are the intersection points of the graphs also. So if there is no intersection point, as we can see here, then there is no solution. Now, how do we know the system is a linear system? We look at the equations. If equations are linear, that means the highest power is 1 on the x, on the y, then the system is called a linear system. So that means all the equations should be linear. If the equations are not linear, they are called non-linear. That will be in lecture number 30. The first method is substitution method. It's not difficult. Substitution, from the meaning, we will substitute something in something. So the steps here are so easy. Choose any equation, 1 or 2, if we have 2 equations. Okay, choose any one you like, the simplest. Solve for x or y from the equation you have chosen, and then call the new equation star. Now substitute, replace, we replace or substitute the result star in the equation we did not use. Now we find the value of one variable, and then we can find the other one, and then we get the solution. Let's see examples to explain the idea. Example 1 has 2 parts. The difference between A and B is A is ready. Directly we can start, choose equation 1 or 2. The second one, we have to rearrange it a little. Now, sometimes we have like A part, ready, little difficult, or more with fractions. So let's take the first question. This is equation 1, this is equation 2. Now we look which one is easier. Just by looking, you can see equation 1, 5x plus y is equal to 4. So I can choose equation 1. Also, you can choose equation 2 if you like, but I choose the easiest. Solve for y because also the easiest. So from equation 1, I can say y equals 4 minus 5x. This is star. So I take the value of the star here, y equals 4 minus 5x in the second equation, the equation I did not use. So I put here 2x minus 3. I have to put bracket 4 minus 5x, this is the star, equals 5. That's equation 2. Now we simplify this result. So I multiply here, be careful in the signs, minus 12 and then plus 15x. You add like terms, you get 17x is equal to 17. Divide by 17x will be 1. Now we found x, we have to find y. Let's go back directly to star because y is ready and waiting to get the value. So y will be 4 minus 5 times the x value. The x value was 1. Can be any number there. And then 4 minus 5 will be minus 1. So the solution will be x and y. Always x at the beginning, y in the second coordinate. So 1 minus 1 is the solution. So which means if you draw the graph of equation 1 and 2, this point here, 1 minus 1, will be the point of intersection. Now you can try, if you like, for a minute, you can pause the video please and try B. Find the solution of this, and then when you are ready, you can go and check the solution. All right, let's go now to B. B, we have to rearrange, I think the first equation, second one, it needs a little arrangement. So the first one, we multiply 3 times x, and then minus 6 plus 7 is equal to 4y plus 12. Rearrange equation 1, leave the x first, and then the y minus 4y. Put the numbers there is equal to 9. Then the second equation, I leave 2x, bring y on this side, minus y is equal to minus 9. That's equation 2. Now look at the system now. This is the system of linear equation. Which equation is easier just by looking? Equation 2. Solve for y. So take y on the other side, you bring this 9, so y will be 2x plus 9. We call this star. If you don't like star, you can call it equation 3, equation A, equation B. It's up to you. Now let's take this equation, star y equals 2x plus 9. We replace it in equation 1, because equation 1 we did not use. So I put, instead of the y here, 2x plus 9. Just simplify and multiply. So when you multiply here, you get minus 4x minus 36 is equal to 9. So add the like terms, minus 5x is equal to 45. Divide by minus 5x will be minus 9. Go back to y in star here, then y will be minus 9. So the solution is minus 9, minus 9. Now let's see another question where we have some variables. Let's solve the system here by substitution method. We have ax plus by equal to 0, x plus y equals to 1, and there is a condition a not equal to b. Let's see if the solution is mn, find the value of m times n. So what do we have to do? Solve it. This is a linear system. Find x and y. X will be the m, y will be the n, then you multiply them. As we mentioned, we can choose the easy equation. I think the easy equation is x plus y is equal to 1. So substitute equation 2. See, this is equation 2. Y equals 1 minus x in the first equation here. So it will be ax plus b. In the bracket, we put 1 minus x is equal to 0, multiply. Then we take a common factor here. See, ax minus bx, we need a common factor, xa minus b, and then we divide by a minus b. Remember, a cannot be equal to b. That means this is not 0. So we can divide here, x equals minus b divided by a minus b. Now to find y, go to this equation. Y equals 1 minus x. So 1 minus the x value. So there is a plus here, and find the LCD. Please be careful there. Then the y will be a over a minus b. So this is x. This is y. So this is mn. To find the product mn, it will be minus ab divided by a minus b all squared. That's the product of x and y. Now the second method, we call it elimination. We would like to eliminate or cancel or delete one of the variables, either x or y. I think it's a good idea that you can read here, obtain coefficients. We need coefficients of x and y, the numbers that are multiplied by x and y, that they differ only in sign, like we need 2x minus 2x, 5x minus 5x, or 3y minus 3y, or 10y minus 10y, so that we can cancel or delete or eliminate one variable. Then we can find the other. You can read this at your leisure time, please. Now, let's see 3 examples here. Solve by elimination. All of these are ready. We can have also equations, systems, that we can make them ready. Let's take the first one, A. So this is equation 1 and 2. Remember now, we need to eliminate. So you have to decide which variable, x or y, you would like to eliminate. See, if I decide to eliminate the x, so I need here something, coefficients, that they differ in the sign. So I need to eliminate x. Let's multiply 3x here by 2, but I have to multiply the whole equation, not only the 3x, remember, even the 8. Now this will give me 6x. So I need minus 6x. So there is a 2 there in the question. So I multiply minus 3, the whole equation, remember, even the minus 1. So it will be 3 there. Now when I add, this becomes 0. This is minus 19y, and this is 19. Divide by minus 19, y equals minus 1 after we add the two equations from the previous slide. Now let's go back to equation 1 or 2 to find the value of x. I have chosen equation 2, so it will be here 2x plus 5 times minus 1. This is the y value is equal minus 1. See from equation 2 there. Simplify the numbers and then you get x equals 2. So the solution now is a single solution, we call it. 2 is the x, minus 1 is the y. Now question 3b, let's do the same method here by elimination. Let's say I need to cancel the x. So this is minus 2. I multiply equation 1 by 2. You see that one here? So this is 2x minus 4y is equal to 6. And then the equation 2 is the same. When you add the equation, you get 0 there. 0x, 0y, all 0 is equal to 7, which is not correct. No way 0 can be equal to 7. That means the lines are parallel. The system, we call it inconsistent. And then we say no solution because the lines do not intersect. So there is no intersection point. That's a nice example here. And now the third one is a little tricky also. We have the system 2x minus y is equal to 1. 4x minus 2y is equal to 2. Let's decide on canceling the, let's say, the x. So the first one I multiply by minus 2, and then multiply with 2x becomes minus 4x, and then plus 2y is equal minus 2. When you add 0x, 0y, 0 on the other side, 0 equals 0. That's different from 0 equals 7 or any other number. 0 equals 0 is correct. So what will happen here? It happens that the two equations are the same here. So from the last slide, we see that 0 is equal to 0. That means the system has infinitely many solutions. Now for the graph, it means that both lines have the same graph. So we say the lines coincide. Now to find the general solution, use any equation. Usually we take the simple one. 2x minus y is equal to 1. Now these two equations are the same. Let's take the easy one. 2x minus y is equal to 1. I will present here two methods, method number 1, method number 2. You can use any one, just pay attention. You can fix the x. So we say let x be any real number. Okay, so just fix it. And then from here, solve for y. Take y on the other side will be 2x minus 1. So directly we can go to the general solution. If we fix the x, so we can write x here, 2x minus 1 in the y, because the solution usually x and y. And we have to mention x belongs to R, which means x is any real number. So you can put x here 0, you get minus 1. If you put x 5, that will be 9. If you put x minus 2, that will be minus 5. So you can put x any number, you will get here the image. So these are the points. Or another way, you can fix the y. So we say let y equals c, or let y equals k, or let y equals a, or leave it as y. So you can write here either y or c or k or any letter you like. So fix the y. Now we take the same equation here. We fix the y. Let's say y equals c. So I say 2x minus c equals 1. So I can solve for x. So x will be c plus 1 all divided by 2. So I can write here x c plus 1 over 2. And then already I have fixed the y and wrote it as c. So x belongs to R. You have to mention that. This is the general solution also. Now, this is the summary of the number of solutions. If we have a system of two equations in two variables, x and y, either we have single solution, So there is one value for x, one value for y. The lines, they intersect. Or we have no solution. The system is called inconsistent. They are parallel lines. Or we have infinitely many solutions. The lines coincide. Let's see another example here. Nice question. Find a value for k for which the system is inconsistent. We have a system here of two equations in two variables. 3x minus 2y is equal to minus 1. X plus ky is equal to 0. If this system is inconsistent, that means there is no solution here. What is the value for k? You can think about it here. And let me show you these steps. Let's try here. Suppose we don't know, and we try by elimination method. In the elimination, let's try to eliminate the x. I have 3x in the first equation, so it's easy to multiply equation 2 by minus 3 so that I can cancel the x when I add the equations. Remember, multiply minus 3. Here you have to multiply minus 3. Also the 0. Maybe it is not 0, maybe 7 in other examples, maybe 5, maybe half. So just multiply by minus 3. So when you add here, see, they add the two equations. You cancel the x, that's 0. And here we have minus 2y minus 3ky equals minus 1. Now, if you can multiply with minus 1 to make the equation simple, you will get 2y plus 3ky is equal to 1. So from the previous slide, we see 2y plus 3ky is equal to 1. Take y as a common factor and then divide by 2 plus 3k. So y will be 1 over 2 plus 3k. Now in the question, it says the system is inconsistent. That means it has no solution. So the whole expression here, the whole y value is undefined. That means we go to the denominator and we make it 0. 2 plus 3k is equal to 0. So 3k is equal minus 2. K will be minus 2 over 3. If you replace this value in the system and you solve it, you will get no solution. Another nice question here, example 5, where we have in the coefficients, we have radicals. Same idea, but it takes time maybe to do. Let's say the solution of this linear system is t comma d. Let's find the value of t times d. So we have 3 square root of 2x minus 4 square root of 3y is equal to minus 6. 2 square root of 2x plus 3 square root of 3y is equal to 13. Maybe it takes some time here. You can try this, please, if you want, and then you can find the solution first. So you can use any method you like. I decided here to cancel the x. See, I have 3 square root of 2x. This is in equation 1. And here we have 2 square root of 2x. So to cancel the x, you can cancel the y if you like. To cancel the x, I multiply equation 1 by minus 2. All of this equation 1 by minus 2. See, this is equation 1 here. Multiply with minus 2, so minus 6 square root of 2 of x plus 8 square root of 3y plus 12 on the other side. Second equation, multiply by only 3. So you have 6 square root of 2x plus 9 square root of 3y is equal to 39. Now we add the equations. See, the same idea, but here we have more radicals. So this one 0x and this is 17 square root of 3y is equal 51. Let's divide by 17. If you divide by 17, you get y equals 3 and then divided by square root of 3 after you divide by 17. So you get 3 there, right? Over square root of 3. You rationalize up and down, multiply by square root of 3. So it will be y will be square root of 3. So let's see on the next slide to find x. Let's take equation 1, 3 square root of 2x minus 4 square root of 3, the y. The y is square root of 3. We found already there, is equal minus 6. So that will be 12 here, minus 12. On the other side, it becomes 12 minus 6 is 6. And then divide by 3. 2 on this side. So 2 over square root of 2 is square root of 2 when you rationalize. Now the solution is x square root of 2, y square root of 3. Nice numbers. So let's find the product t times d. It will be square root of 6 is the answer. Now in this pre-calculus lecture number 29, you can find 2 parts of practice questions. Part 1, there are 3 questions you will see now. And then the solutions will be in another video. Part 2 will be 6 old exams questions. You can try them also, and the solutions will be in another video. So part 1, we have 3 questions, linear systems in 2 variables. Look at this nice system here. Solve this system, the linear system, by any method you like. 2x minus 1 over 3 plus y plus 2 over 4 is equal to 4. And down we have x plus 3 over 2 minus x minus y over 3 is equal to 3. Here we have fractions. Before you do anything, you have to rearrange both equations. Now here we have a little application, a nice question. If the graph of this line, y equals ax plus b, passes through the points minus 2, 1, and minus 1, minus 2. Find the values of A and B. Try to think, please, and see. Now, question number 3 is a little harder. Question number 3 is similar to question number 2, but I put more difficult equation. If the graph of the equation y cubed is equal ax squared plus b, the graph passes through the points, the same points, minus 2, 1, and minus 1, minus 2. Find the values of A and B. Try to do these 2, and then you can find here the answers for question 1, 2, and 3. So the solution of these 3 questions is in one video. We call it part 1, linear systems with applications, extra solved questions. Now we have part 2. There are 6 questions. Linear systems in 2 variables. Question number 1, solve the system by elimination method. We have some variables there. Ax plus by is equal to 0. A squared x plus b squared y is equal to 1. Then question number 2, solve the linear system. We have some fractions there. Very similar question number 3, but there's a difference in the solution between 2 and 3. You can check and see why I put these systems here. Question number 4, if the solution of this system here is mn, find the product m times n. So first you have to rearrange equation 1, equation 2, then use any method you like, find x and y, and then you can call them mn, then find the product mn. Question number 5, we have the system has here, the system 2x plus 5y plus a equal to 0, 3x minus by is equal to 2 has infinite number of solutions. Find the product a times b, and it is a multiple choice question. Question number 6 is also an application. The sum of 2 numbers is twice their difference. The larger number is 6 more than twice the smaller. Find the product of the numbers. This is question number 6. Here you find the answers for these 6 questions. So for complete solution only for these questions, please, the 6, you can find them in the video. Linear system of equations, lecture 29, pre-calculus, all the exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is pre-calculus course, lecture number 29 about linear systems. I hope I can see you in another video with another topic. Thank you for listening.